hello viewers. In this video, I'd like to discuss about the dynamic packet filter. As I told you in my last video about a static packet filter. So dynamic packet filters are called stateful because they also consider the information received from the previous packet, as in this case of static packet filtering, the attackers cannot spoof the communication in this case as it has the information about the previous packet and of the source of the communication. Can also be used in case of UDP packet. Yes, you know that user datagram package that comes from the transport layer information, and it is like the video communication while we are making, and you know that TCP packets are like you are doing the bank transaction. In that case, you have to have always need a SYNC and three-way handshake TCP communication. So that is done in by the static packet filter, but in dynamic packet filter you can do this UDP packet filter also. In that case, if packets are lost, that is also allowed, and it is complex and expensive to implement dynamic packet filters, mainly in professional all case, like you are doing this bank transaction. In that case, they have this dynamic packet filters, and I'm gonna discuss you about now. I will show you in some lab practice for this static and dynamic packet filtering rules later by using Linux IP tables. But before that, in this video, I'd like to discuss some more theoretical part. One of the most important uh, question is for what are the limitations for the packet filter. The first one is no user or application specific filtering is possible. It means one computer may be used for different user, and maybe there can have different applications or software what is generating the packets. But when a packet is sending from a source machine to destination machine, in that case, only the header information of the source IP address or source port number will contain. So there will be no user specific information. That is one of the limitation of packet filtering. That is saying all the user using a particular machine will have the same rules on the firewall. Thus, there is no user specific rules. Second one is use of only transport layer information to identify the application layer information, such as like the packet filter only taken into consider the detail about the router of the packet, and there is no rules about the information content in the payload part of the incoming packet. That is also one point. But let's say you are using an HTTP connection, and then for filtering that you are using this port 80. That is port number 80 is used for identify this application layer protocol HTTP. So that is also one problematic, because once a packet is coming to filter, it will only filter the header information, but in the payload the segmentation has a problematic, and because those payload segments doesn't have this information of filtering packet. So fragmentation is problematic. Now, three, application having varying of port numbers. So this is another limitation, because there are certain port numbers like file transfer protocol. They have different port numbers for uploading or downloading maybe. So attacker can use a different channel to negotiate it, those port numbers and can attack. So applications which have a different varying having varying port numbers is problematic. The most important limitation of firewall is called, you can say, the most limited important limitation for packet filtering is tunneling and encryption. In some protocols, we can tunnel the information by encapsulating it into another protocol. If the packets are now then um, then the packet filter cannot decrypt the packet. So that is another problem. Tunneling and encryption is problematic, but it is for, I mean, tunneling and encryption is totally opposite of what firewall is doing. So firewall is um, protecting incoming packets to intranet inside, and while tunneling and encryption are making the packets secure and making a hole inside of the firewall. So in the next chapter, while we will discuss about VPN, and there will be some VPN SSH tunneling, then you will be able to more clear about this information. So let's see the next topic, that is called, by the way, this scripting was written by Prachi Agarwal from the lecture, so one of my classmates. So I'm using her script because she was explained in her notes, it's very well. And yeah, so next topic is called um, network address translation. So NAT is, what is NAT? Simply, you can say the NAT converts a private IP address to a public IP address, and there are certain range of IP address that are fixed for private use and others are available publicly. The private IP address are generally employed by the intranet, and it is not possible to route to this IP address as they are not directly connected to the intranet. So the situation is here. I want to explain it simply in this video, and next video maybe detail. So you can see that in this figure that if a machine from the intranet, like let's say A, wants with the port X wants to communicate with some destination D, Y, what is in internet, in that case, this NAT will translate this private IP address to a public IP address N, and then there will be a net binding of AX with NZ, and then it will send it to D, D with port Y. So how the process will work, I will discuss in next video. NAT. Thank you for watching this video.